Good evening. My name is Bruce Gillette. I am one of the pastors here at First Presbyterian Union Church in Owego. We are very happy to have all of you here, and we'll begin the evening by talking to the one who created the river and everything else. Let's have a brief word of prayer. Let us pray. Loving God, we give you thanks for your creation. The stories of rivers start in Genesis and go through the Bible to the last chapter of the book of Revelation. They are part of your creation. And for those who live in this region, we are blessed with the ancient Susquehanna River. We thank you, O God, for your blessings. And we thank you for this evening's teacher, who is a blessing to our community as well as the university. Be with Pete in his teaching and his service. Be with us all in this time together. Hear our prayers, spoken and unspoken, in the name of the one who we celebrate.
Mapping
This
the historic
holy
Susquehanna River.
Amen.
The things on
Amen.
YouTube.
I ask everybody to please mute themselves.
Look up sometime.
Let's see if we can get them.
There we go.
Carolyn, can you help me out? Go to the people who have not been muted and so do so. Okay. All right. You will see it in his opening slide. We are very grateful to have this professor of geology and environmental studies from Binghamton University. He, I believe, did his undergraduate work at Stanford and then University of Arizona for his doctoral work, if I remember correctly. And we are very happy to have him with us. So take it away, Pete. Thank you.
All right. So first question is, did I get it set properly for you?
Oh, you need the slideshow set.
No. Okay. Still having that problem. All right. Give me just a moment to fix this up.
We're trying to turn off the background, ask everybody to please mute. There's somebody.
Right. Get my glasses on so I can actually see what I'm doing for once. And slideshow, let's do that. Nope. Still not getting it. Had this set just a few minutes ago and it was working fine. And then
What we'll do is open it up in PowerPoint and then at the top screen, go to view and view.
now the problem is having my second screen on. So let me turn that off and this should then work fine. All right. I think that will work a little better.
Okay, thank you.
All right. So a real pleasure to be with you tonight. When Bruce asked me to talk, he said, you know, let's talk a little bit about the history of the river. And so I think I'll start there and we'll take a look at a geologist perspective on the Susquehanna, both in terms of its long-term history and then in terms of its hazards. Come on, this should go forward. Had this working fine. Why is it not working now?
Okay.
All right, I'm going to try this again. It just hung my, sorry about this, folks. It just hung my computer. Okay, I can do it that way. All right, so the river journey I want to take you on tonight is kind of going to have two parts. The first part is looking back as a geologist, which means looking back into deep time. Talk a little bit about my misspellings of piracy, but talking a little bit about what we can learn from the landscape of the Susquehanna, some evidence from the lower part of the river down in Pennsylvania into Maryland that gives us some ideas of how old this river really is, and then some of the changes that have happened in probably the last few million years up here in the northern part of the river. Second part of what I want to talk about tonight is really focused on us living with the river and indeed more specifically about floods. Of course, I know many of you, if not all of you, were flooded during the 2011 flood. And I want to put that into a little context, both in terms of the history of the floods in this region, as well as thinking ahead into the future as to what future flood potential might look like.
We have stopped more than 4 million with the rainfall.
Okay, so first question I want to ask is, how old is the Susquehanna? And I'll start with one view, and it's probably the one that you may have heard. This one just happens to be a quotation from a paper that an engineer at New York's DEC wrote a few years ago in the publication Clearwaters, saying that geologically, the Susquehanna River is considered the oldest, or maybe the second oldest major river system in the world, dating back to the Paleozoic. There is evidence that the flow of the ancient Susquehanna predated the formation of the Appalachian Mountains over 300 million years ago. So that's one view. Different views. More recent work, I think, and well, I will say that that view is controversial, as is the second one. So the second set I have here. But the reality is that what we see today as the Susquehanna River hasn't been around for 300 million years. The rocks have been. But the rocks that are present at the surface today, whether you're in Pennsylvania or up here in New York, were buried. They became rocks. They were parts of rivers. They were parts of the ocean. Buried, became rocks, got uplifted. Material above them got eroded away. The river that we see today is probably at most something like 60 million years old. That's probably had its origins in the opening of the modern Atlantic Ocean that started around then, and may well be as young as about 15 million years old. And the story I want to show you is really kind of looking at that in the context of so this is an image. Okay. Am I unmuted now? Okay. Hopefully. Yeah. Okay. So this is a Google Earth image of our region here. The familiar Susquehanna River coming through here, down into Pennsylvania, coming back up through Binghamton and and over to almost to, I didn't quite keep it to Owego. But the other things that I wanted to point out to you are the Delaware. The West Branch and the East Branch of the Delaware come down here to what's now the border of New York and Pennsylvania and swing south. And so one of the questions that geologists have asked for really over a century is this a matter of, or a history of change in this region that is involving one river grabbing another? So this little cartoon here shows the idea of what we call headward erosion and stream capture, or stream piracy. Here we have here we have a river system, two branches to it, flowing down in this direction. This other river has been gradually growing as it erodes its way sort of upwards across some kind of a mountain divide or something like that. And eventually it erodes through and grabs the flow of this river, so that over on the right-hand side here, you end up with this new river going like this, the older river continuing in this direction. In the context then of our region here, and I admit this isn't the best map in the world, but it gets the point across. And I'll show a slightly better version of this in a moment. But if we look at the Shenango and the Susquehanna and imagine how all of these rivers might have been connected in the past, what you have is essentially a whole suite of river systems that look like they ought to have been connected in the past. So if I go back for a moment here, when you look at the Delaware, and you see where it goes down to deposit, it's kind of hard to imagine that it didn't connect across into what's now the Susquehanna. And yet there's certainly a fairly impressive mountain between them today. So this notion of a river capture is something that geologists have described and hypothesized literally for over 100 years as being the way that the rivers in this region have evolved. So I'm going to give a little bit different story, or a different part of the story here. The other element of the story that's very important is the glacial history that covered our region here in New York and extended down into Pennsylvania, down to the Poconos. This map is showing the extent of the last glacial period down into northeastern Pennsylvania, across the one corner of New York that was not glaciated, which is the Allegheny State Park area, and then down across this way and towards Ohio. If we take a look in Pennsylvania, so superimposed within here is the Susquehanna River. So here's the Susquehanna River coming around through this portion of northeastern Pennsylvania. And the last glacial period extended down essentially in this area down to Interstate 80, but older glaciations extended farther. And geological studies have shown that what are shown here is PI, called pre-Illinoian. They really go back at least 600,000 or 700,000 years, and probably older than that. So one piece of the geologic history here is that we've had periods of glaciation that certainly have had big impacts on the landscape. And that then leads to sort of allowing this particular explanation to make sense. So this is from a paper that was written back in the 1930s, but the ideas are probably pretty good even today. And that is that the Delaware, what's now the Delaware River, its two branches, were probably all part of one river system. Whether it looked exactly like this with the Susquehanna doing this big bend through here, I don't know. I'm not really certain one way or another, but that would be sort of the early stage. And then a river started to develop and essentially move its way or cut its way upward and grabbed the East Branch. So the East Branch then becomes a piece of the Delaware. That continues on through time, and it grabs the West Branch, so that we end up with the West and East branches becoming part of this river system, even though it looks like they ought to connect off in this direction. So that is, whoops, I'm sorry, I'll get to that one in a moment. That is largely hypothetical. There's no really direct evidence to prove this, but certainly in terms of the shape of the rivers, the elongated nature of the Delaware river system, and the shape of the Susquehanna all suggest that there was flow that was going across this part of New York and northern Pennsylvania from northeast to southwest. Maybe this piece of the Susquehanna did the same thing as well. We don't really know when that happened directly, but I will give you some indications of it from information farther south. So if you go farther south into Pennsylvania, the thing that's really impressive about the Susquehanna is it makes these cuts through the big ridges that create are the so-called valley and what we call the Valley and Ridge province of Pennsylvania. These ridges are held up by sandstone layers. Typically, the valleys in between have either shales or limestone rocks. The shales and limestones are more easily eroded. The sandstones not so much, and so the the sandstones stand up as the main ridges that you see when you drive down to Harrisburg and cut across through this suite of ridges. So the river's done that, and really one of the fundamental questions is, when did it do that? So the kind of the school of thought that says this river is really ancient imagines that the Susquehanna, or some version of the Susquehanna, existed when the mountains were first built, and that over time the Susquehanna has more or less stayed there. And as the whole region has uplifted, and then other streams and rivers have contributed to erode the mountains down, the Susquehanna remains there. I find that personally kind of hard to believe. There certainly had to have been rivers flowing across the region in the deep past, but whether this particular river that we see today bears any resemblance to it is sort of doubtful. What is clearer, well, I guess this illustration kind of gets to the point that you can have something like what is now the lower part of the Susquehanna, and there could have been another river, and there may well have been a different river flowing in a different direction around these ridges, sometimes cutting through, sometimes not so much cutting through and going alongside. And then over time, as the ridges basically become more established because of the greater difficulty of eroding through them, these individual streams can actually start to coincide and develop into single ones. So very much the same sort of thing as has happened, or we think has probably happened up here in New York. The result of all of that is the development of a river that probably had different elements to it. It may well be that the part that's here in New York drained at one time to the Ohio, that the part that's down in southern Pennsylvania always drained down into what is now the Chesapeake Bay, or at least into the modern Atlantic. But that would be true really only for about the last 60 or 70 million years, something of that sort. So lots of time involved in basically this river coming together. The clearest evidence from this region, especially a little farther south in Pennsylvania, is that the oldest deposits that geologists can with certainty say relate to the Susquehanna as we basically see it today date back to about 15, maybe a little bit later, a little older, but probably about 12 to 15 million years ago. That isn't to say that the Susquehanna is young. It's also to say that the Susquehanna isn't quite as old as is often depicted. So I guess that's the kind of take-home message from the first part of this. How old is it? Well, it's certainly prior it existed, probably pretty similar to its current orientation prior to the glaciations that have occurred over the last million and a half to 2 million years. The gravels in the downstream area down in southern Pennsylvania and Maryland suggest that there was a Susquehanna River in that region at least, say, 10 to 12, maybe 15 million years ago, and that it was bringing in rocks that are found certainly farther north in Pennsylvania, and probably rocks that are found up here in New York. So suggesting that certainly by that time it was a river that was very much like it is today. So the general understanding today, I think, is that these rivers basically in pieces grew headward, grabbed pieces of other rivers that existed. In Pennsylvania, they eroded through the resistant ridges, probably at locations where there were some discontinuities in the rocks that made it a little easier for the rivers to break through. And it ultimately joined together into a single river system. So so the Susquehanna River is much younger than the rocks. It is older than dirt. Sorry, I had to throw that one in. So that's kind of part one of this story that I wanted to talk about. But I really want to spend a little bit more time talking about the river today and the modern river and how it really impacts us here. Before I really get into talking about the floods, I want to just sort of step back a little bit and things I don't actually have on the slides and just comment a little bit about sort of the history of the use of the river. So if we look back, say 200, 250 years prior to European settlement in this region, the indigenous peoples, the native peoples, used the river for transport. They used the river floodplains for agriculture. They lived with the floods that they had by usually placing their villages up high above where they saw evidence of flooding occurring, but very typically would have their fields down in the valley bottoms and in the floodplains to take advantage of the rejuvenation of sediment and silt that would come during flood events. So that's kind of one stage in the history. The Susquehanna certainly was a river that was utilized for transport and for commerce once settlers came into the European settlers came into the area, and you know, as with most of the river systems in places like New York, either directly using the river or constructing canals alongside the river to take advantage of the waterway as a means of transport. And as is true really all through the Northeast, the Susquehanna in places was also used for mills. So small dams like the ones we have here in Binghamton were constructed in order to localize some of the flow of the river or some of the drop of the river in order to run mills. Our recent history, you know, more recently, I think in terms of, let's say in the last century or so, people had tended to turn away from the river, seeing it as more of a hazard than a friend. I think that is a function largely, quite honestly, of the history of floods in this region, and um, the the fact that we moved into different kinds of transport and we're no longer dependent upon this river for transport. So now getting into what I have on the slide here, the Susquehanna River Basin Commission, which oversees use of the river and river waters, describes the Susquehanna River as one of the most flood-prone rivers in the country. The damages from floods, when you look at the entire river all the way from here in New York all the way downstream, is on average in excess of $150 million. And most locations have flood-prone areas. I noted major floods in New York. I'll show a different slide in a moment that extends this record back a little farther, but floods that have had direct recordings of the elevations and the amounts of water occurred. The largest ones in this region in 1935 and 36. If you're over in the Chemung River and over to towards Elmira and Corning, the big flood was in 1972. And then we had our two major floods of record in this area in 2006, and then most recently and largest in 2011. So since I'm speaking to a group in Owego, I have to have a couple of pictures in here, probably unfortunately reminding you of what the village looked like in the midst of that flood in 2011. I should tell a little story about myself in this regard. We live about a block away from the Susquehanna River. We are up pretty high. When we bought the house, I took a look at the flood maps. I looked at where the house was. I said, well, most of Binghamton and Endicott and Johnson City would be flooded before we were. So we might not be able to get out of our house in the flood, but we probably wouldn't have river water in it either. But when and there's a block away from us down at the riverbank, there's a flood wall. When the 2011 flood occurred, the flood wall, the river got within about 1.5 inches of the top of the flood wall. Our neighbor's daughter lived at that time in an apartment about 5 or so blocks away. And that particular location where there's a levee along the river was just a little bit lower. Water came over the top. Her apartment, unfortunately, was at ground level facing the levee. So the water came over the top and right into her apartment. When she came back after the flood waters had receded and been pumped out, she found that a zucchini, which she had left on her kitchen table, was sitting on top of the highest cabinet in the kitchen within about 1 inch or 2 of the ceiling. So her entire apartment had been flooded. And there were stories of like that, of course, unfortunately for so many people with really major losses. So as I say, we've had our two biggest floods in fairly recent time. The 2006 flood that occurred in this area, excuse me, I'm gonna have to plug something in. I hope this doesn't mess up what I've got here going. The 2006 flood in this area was caused largely by a very prominent rainstorm that was essentially a stalled front that stayed out over the Catskills, dropped a large amount of rain in that area, and then flooded, eventually produced flooding in the Binghamton area. I recall that one well myself from the fact that when the floods occurred here in the Binghamton area, it was a beautiful sunny day. It was the rain had stopped the day before, and it took a while for the floodwaters to get here. So that produced this effect at Lourdes Hospital here in Binghamton. They had tried to put a temporary dike out around the building, unsuccessful, unfortunately. It flooded the entire lower level of the hospital, and it, if I remember right, cost them about $12.5 million in damages. And then we had the 2011, and so here's Owego. Here's the highest amount of rainfall from Tropical Storm Lee, and that was sufficient in and of itself, sitting around 12 inches of rain. to have caused flooding, but it was, of course, on top of the remnants of Hurricane Irene that had come through the Catskills and the Adirondacks a couple of weeks before. And so the ground was still very wet in this area. It had been a wet summer to begin with, and this happened. Whoops. And let me actually, before I get to that photo. So what was different between 2008 and 2006 and 2011 is that in 2006, the storm was primarily over here in the Catskills. It took a while for the floodwaters to get here. In 2011, the storm center was right over us in this region. And so Owego, sitting right here in the midst of the heaviest rainfall and right downstream of this area of real heavy rainfall, was unfortunately just in the wrong place at the wrong time to get really hammered by the flood. Anyway, this was what happened at Lourdes Hospital in 2011. I'll talk a little bit more about what they did between 2006 and 2011 to protect the hospital a little bit later on. And then here's another view of Owego. And I promise I won't keep showing pictures of Owego in flood. But it does show a couple of things that are pretty important. So obviously you can hardly see the riverbank. The river is clearly above bank, as is Owego Creek. So for Owego Creek, you had water coming down the creek. You had water backing up from the Susquehanna River as well. And so virtually the entirety of the village, was flooded. So this just lists the 10 highest historical crests of the Susquehanna River at Binghamton. The reason that, and this is produced by the U.S. Geological Survey, the reason they chose Binghamton for this is because the bridge that exists on Washington Street, what is now a pedestrian bridge across the Susquehanna River, there's been a bridge in that location since the 1830s. And so some of these older floods are known because the height of the flood at Binghamton was measured at the bridge. We don't really know how big the floods were. We know how high they got. We don't know how big they were. And by big, I mean how much water was flowing. And the reason for that is today we have gauges, which I'll talk about here in just a moment, that quantify how much water is flowing past a location. Back in the 1860s, we didn't have things like that, or in the 1840s, we didn't have things like that. But what we did have, of course, were bridges, and people knew how high the water got on the bridges. So that's how these heights are determined. The reason we can't tell how much water was flowing is because the configuration of the river has been changed by putting in flood walls and levees. And so today we know what the relationship is between the height of the water and how much the stream flow is. But back then we really don't know that. So anyway, but you can see in this list that, these two of the biggest floods of record, we go back into the 30s, and in Binghamton, 1936 had been a really big flood. It was the fourth largest historically. 1948 was also a really big event. You can see some of these others. But what's also missing in this record are some other floods that occurred in the 1990s, 3 of them, 2 in 1993 and 1 in 1996, that weren't quite as big in Binghamton, but were, once you got down to, would have been within this list if I showed you a list from, say, a place like Vestal or Owego. Okay, so a question that I've been asking, frankly, ever since the 2006 flood has been how often and how rare are these floods? And then a related question, 2 related questions, one of which I've listed here, the other one I haven't. But how rare are these floods historically? How characteristic are they of the largest floods that have occurred in prehistoric times on the Susquehanna River? And then a question that I think is of paramount importance as we think about the future is the fact that the climate is changing, also changing flood potential. Now, I'm not the first person to ask these questions. I have my own answers that may be a little different than what some others have, and I'll comment about that. So in order to try to address these questions, we need to look at past floods to give us some handle on what's been going on. For the most part, that's going to be based upon direct measurements that we have. As I said, and I think part of the discussion of what I do in the little blurb about this talk mentioned that I've been doing some work trying to understand how frequently, or how large prehistoric floods have been. I will just say that not there yet. Hopefully that will be something I get done before I quit looking at geology. But we want to use the past information, whether it be from historical records or from prehistorical records, to estimate the potential for future floods. How likely are floods of a certain size to occur in the future? Then the next step is to start thinking about, is the predicted flood potential based upon past floods still relevant when we think about changes that are going to be happening and already are happening, really, in terms of the frequency and intensity of storms in this region? So I want to talk a little bit about that. The way we get information directly about floods is from gauge records, stations that are set up in order to be able to analyze constantly analyze how high the water level is in the river. And by making measurements of the actual volume of water or discharge of water that's flowing through the river at different times, calibrate the height to how much water is flowing through. So there are essentially continuous, I said discontinuous measurements in Binghamton, but there are continuous measurements that have been made in some longstanding gauge sites on the Susquehanna in New York, one up in Unadilla, one in Vestal, one downstream in Waverly, and then a station just upstream of Binghamton in Conklin has been around since 1913. And there's one on the Shenango River that's been around that long at Shenango Forks as well. So we have a number of locations within this area that provide us direct information about the size of floods. So just to kind of point out where these places are, there's the Unadilla station up here, up in the area near Sydney. We've got the Conklin station just after the Susquehanna comes back from its little visit down into Great Bend in Pennsylvania. There's a station at Vestal. There's a station at Waverly. There's a shorter term station that's been operative since 1988 in Owego. And then in Binghamton, there's not an actual measurement station, but there are measurements that are made routinely of the height of the water at the Washington Street Bridge. Okay, so let me pop forward here in case you aren't familiar with how these things operate. So this is a picture of the gauge house or gauge station in Conklin. And the way these things operate is really pretty simple. They have a set of pipes or intakes that are within the river, take water into this housing. The water will then equilibrate just because of air pressure, will equilibrate to the same level within the housing as it is in the river. So if the river's down here, the water in the housing will be there. If the river's here, the water will get to there. If the river's up here, the water gets up to here. And so you can record that height constantly. That's sent out these days by a satellite to a central station. The major station or the major gauging stations in the region here are all being operated by the U.S. Geological Survey, and so they keep track of what the height is. This is an example of a record. This is from Vestal from the 2011 flood. You can see that once the rains came, the river rose very rapidly, reached a peak that, as it turned out, was just an inch or two below the top of the levee at that location. They lost their power at the gauging station during the latter parts of the flood, interestingly enough. And so you don't have a continuous record here, but you can see basically what was going on. Okay, and so the river, in fact, had gotten up to a height of a little over 35 feet during that flood. So that kind of information is utilized to figure out and compute what the potential for flooding is. This is the record from Owego. There was a good measurement made from the 1936 flood, so that's a point over here. And then these are the sizes of the largest flows that have been recorded in Owego on the Susquehanna River in each year since 1988. Okay, so we take that information, basically plot it up, and fit a curve to the data. there's a very particular kind of curve fit that's utilized that was developed, or an approach that was developed by a committee of government hydrologists. So it's a very consistent kind of approach, and it has all of the problems that are associated with doing things by committee. Let's just say that. In any event, this is a fairly short record. So if you take the largest event here, which is the 2011 flood, it looks like it is a fairly frequent event, right? Because it's happened within this short period of record. So that's not helpful, because we don't really know whether this is something that should fit on this curve, or if it's really a much more unusual event. So we need to look at longer records, and this is the record from Conklin. So this one goes back to 1913, and you can see that when you do the best fit line to the data, you can see that this fits pretty well, pretty close to being on the line, and suggests that really the 2011 flood, while it was certainly a very major event, is not something that would be all that unexpected. It has something close to, not quite, but close to a 1% likelihood of occurring in any given year. So that's important to appreciate that degree. Okay, so those kinds of analyses allow flood forecasters, flood managers to look at flood potential. It's the basis for determining where you need to buy flood insurance if you're within an area that should or is predicted to be inundated by a flood that has a 1% chance of happening in any given year, which is typically called the 100-year floodplain. So these are used in very practical ways as well. Before I'll say this. So one question is the recent flood trend showing us that there's a change? And to look at that, we have to look at the frequency of these extreme events. So is the likelihood or the size of an event that we expect to have a 1% chance of occurring in any given year changing? First, let's look at some other data, and that's how much is precipitation changing. So here in the Northeast, so this region over here, precipitation has been going up over the last few decades. Well established, or it's well documented in most regions in the Northeast, including here in the Binghamton area. But it's not only the total amount of precipitation which has been going up, but also the intensity of it. So this set of graphs shows the same kind of information, except now for heavy rainstorm events. And you can see that they've gone up much more substantially in recent decades here in the Northeast. And really that's kind of true of most of the northern tier of states. So the trends towards these kind of increased intense rainfall or even snowstorm events shows that in this northeastern region, we're looking at increases of 85% over the last, and this one's over the last, what are we now, 70 years, almost 80 years of record, looking at New England and in this area here in the mid-Atlantic, just a tremendous increase in the intensity of storms. Those are the kinds of storms that produce the big floods that we see in this area. Okay, so one way to think about this is, has the probability of a large flood event increased? Has the size of an event that we think might have a 1% chance, or once in a 100 year on average kind of event increased? And so we can look at this in a number of ways. This is a simple way to do it. We take a portion of the Conklin record, first 50 years, and then we'll look at another 50-year record. So if we look at this first 50 years, and I look here at this point, which is the 1% likelihood flood, comes out to a value that is sitting here around 62,000 cubic feet per second. That's a pretty substantial flood. If we take the same sort of approach, but look at the next 50 years, and we look at what this 1% flood is, it's now sitting here at 80,000 cubic feet per second. So Now, that is being driven in part by the fact that we've had two very large floods in this time frame. But to be honest, within this time frame, we had three good-sized floods in the Binghamton region, and two of which had significant impacts in Conklin. So it's not like these floods are completely driving this, the 2006 and 2011, but they certainly have an impact there. So another way I've attempted to look at this is to look at the record from Conklin, because it's a very long one, take a 50-year portion of that record, compute what we would predict to be the size of a 1% chance flood, and then just keep doing this. Keep doing this, and then average that out. So this line is basically looking at, for any given year in here, and looking at the suite of flood events that occurred at 50 plus or minus 25 years around that, what would you be predicting the size of this 1% flood or 100-year flood would be? And what you see here is that in the last few decades, this jumped. Now, this peak in it here is reflective of 2006 and especially the 2011 floods. As this thing continues, as we go forward in the future, if we don't have any more big floods, this will come down a little bit, but it's still going to stay very high. Then this one is the same kind of a illustration for Towanda down in Pennsylvania, and you can see that there it started being influenced by the 1972 flood. But again, what we're seeing is really a different behavior in the early part of the 20th century versus the later part of the 20th century and 21st century. So we're seeing this big change. So the take-home message on that is flood frequency does appear to be changing. This is something that the Army Corps of Engineers has recognized as well. But what they concluded was that the degree of change that we're already seeing, while it's real, is not significant in their view. And they further concluded that while it is clear that intensity of storms already is increasing in recent decades, and by the way, is projected to increase more in the future, that also has too much uncertainty in terms of their projections. So their conclusion is we can't really tell. My view on it right now is that the floods have become more frequent. Significant floods have become more frequent in recent decades, not just those two in 2006 and 2011, that the size of a 1% flood is increasing. This is something that the Federal Emergency Management Agency is aware of, and has addressed with some preliminary flood maps that have not met with a lot of excitement from people, because it ends up saying that a lot of properties that we thought weren't necessarily flood prone, in fact, probably are. And the bottom line is that this is, while it's not entirely by itself proof of climate change, it is certainly consistent with what we're seeing. Just the last couple of notes then, before I wrap up, I just wanted to say, okay, what do we do about these sorts of things? And I'll wrap this up very quickly here. Oftentimes people say, let's change the nature of the channel, either by dredging out the sediment that's in the Susquehanna River or raising the levees. The Army Corps of Engineers concluded that raising the levees simply was not feasible, or well, was not cost effective. So that's their conclusion. Dredging has been done in different places in the Susquehanna, including in Owego. Unfortunately, it doesn't last long. This river moves a lot of sediment through. And I recall giving a talk back in about 2007 or so, I think, and the mayor in Owego was mentioning to me that, yeah, they had contracted to have the sediment that comes out of Owego Creek into the Susquehanna dredged out in order to try to deepen the channel. And it lasted for at least a couple of years. So dredging is useful probably only if you have small stream infrastructure along small streams, but on the big river, it frankly isn't going to work. But there are some cases where investing in additional flood protection is probably worthwhile. And this is what Lourdes Hospital did. So between 2006 and 2011, they set up, and if any of you go to Lourdes, you're probably aware that there's this wall with openings around it, or openings in it, that have been set up around the hospital. So what happened then in 2011 is the waters came in, they closed off this wall system, and it actually stopped floodwaters from getting into the hospital. It was close, but it was successful. So they basically spent, I think if I remember right, they spent about $10 million and saved themselves probably 25 million from potential damage that would have happened from the 2011 flood. A lot of what can really be done are ecologically sensible solutions, which doing things like enhancing natural wetlands or restoring natural wetlands, allowing vegetation to regrow along the floodplain so that when floods do come through, it slows the water down. And what that means is that then it doesn't rise as rapidly because it's getting slowed down in different places. It's all part of what we call reacquainting the river with its floodplain. And the Federal Emergency Management Agency has gotten increasingly involved in doing that by supporting buyouts of very frequently flooded locations, frequently flooded buildings, but that does come at a significant impact on the tax base. So things like what were done here in Owego after the 2006 or 2011 flood by a number of homeowners, of raising the house up, of providing a flow through ground floor level that would allow future floodwaters to flow through, not blocking them, and also essentially keeping the main part of the house dry. So there are a lot of different options that are available, and so that's plenty to talk about. And I'm more than happy to take some questions, but I will stop the sharing at this point. So Bruce, you are still muted as well. There we go.
The easiest thing we can do here would be, if you're looking on your Zoom at the bottom, there is a category that says reactions. And if you click the reactions, there's one that says raise hand. Raise your hand, and that brings you up to the top of the screen on Zoom in the gallery. And then we know you have a question. Kevin Millar has one. Take it away, Kevin. What's your question? You do have to unmute to be heard.
Yeah, a little mute delay. I was just wondering what the effect of filling the floodplain in along the river upstream affects downstream flooding.
So every time that the river is filled in, or for that matter, really every time that we put levees in or flood walls in, what we're doing is we're restricting the available area for flooding to occur when it does occur. What that means is that within a zone where you've filled in the river or raised the floodplain or put walls along the side of the river, means that the river height is going to increase for a given amount of water coming through. If you're downstream from that, immediately downstream from that, that means you got more water coming at you, higher water coming at you. It's going to produce a greater flood problem.
Okay.
Most of Route 17 construction from Vestal probably to Waverly basically impacted floodplain very negatively.
Yes, absolutely. Not the only place where, the only thing that's done that, but yeah, it did. It kind of provides an artificial levee where there wasn't one before.
Okay. Tom, you have a question?
Yeah, I do. Pete, I'm originally from Warren, Pennsylvania.
Okay.
That's a small town right below Jamestown, right under Chautauqua Lake.
Yep.
My father was from Bath. So I spent all of my young life, and by the way, I'm now in my mid-80s. I spent all of my young life traveling back and forth between Warren and Bath, New York.
Okay.
I always used to look at these levees around the Cohocton and Bath. And I used to ask my dad about, because you can take your shoes and socks off and walk across the Cohocton most of the time.
Right.
He told me about the 36 and 39 flood and blah, blah, blah. Well, now I've been up here since 1966.
Hmm.
And what's always fascinated me is the Chautauqua Lake drains out into a large creek. It gets very large by the time it gets to Warren. It's called the Conowongo Creek.
Okay.
It's at least the size of the Shenango River. And of course, it goes into the Allegheny and the Ohio, Mississippi, up down in New Orleans. Right over the hill is Lake Erie. And
Yeah.
when I say right over the hill, I mean, it's maybe 15 miles.
Yeah.
And of course, that gets into the Great Lakes system and goes up, the St.
Right.
Lawrence and out into North Atlantic. Then I moved up here. And now I've got this Susquehanna Basin, which, is drains everything from, I don't know, it must be, is it Andover, Wellsville, wherever that is over there, to the east. But I heard you say that there's a theory that maybe once upon a time that this Susquehanna Basin must have drained west, because I heard you say go into the Ohio system.
Yeah.
So where the heck would that break through to get there?
So, similar to even just the Susquehanna Delaware difference here now, there's pretty good evidence that over the last 20 or 30 million years, the East Coast has actually seen some uplift, sort of large regional scale rising of the land. So there become then places where some of that gets a little bit greater than others, and some of it a little lesser than others. Where, so I guess what I'll say is the evidence that suggests that most of these rivers drained out towards the Ohio actually has to do with some of the deposits. Some of the deposits are now rock, related to the Ohio River and Mississippi River system. And especially some of the offshore ones that indicate the rocks had to have come from someplace out here in the Northeast, that you don't have the right rocks that are exposed within what are now the Ohio or Mississippi River systems. So those are the kinds of evidence that geologists use, kind of far distant indicators of where things must have come from. How they got there, exactly how the landscape changed as a result after those kinds of times is really, it's ultimately very speculative. We really don't have any direct way of making measurements of those sorts of things. So we can speculate based upon the shapes of rivers and valleys and say, okay, well, if they're heading off in this direction, that means they should have probably continued to flow in that direction. Rivers don't normally make the kind of right angle bends that the Susquehanna does, or that the Delaware does. That's an unexpected kind of behavior. They tend not to want to make that degree of bend on the scale, on say a subcontinental scale that what we see here. So that's really the crux of the argument.
Can I ask you one more quick question? This is almost a yes or no.
Okay.
In Michener's book, Chesapeake, he makes the early claim, and I always, put a lot of trust in this guy's geological backgrounds, but he makes the proposition that the Chesapeake was once upon a time the Susquehanna River, and all those other rivers just flowed into the Susquehanna, and it was a monster storm in the Susquehanna that created the Chesapeake. Is that got any credibility at all?
Well, so the Chesapeake Bay is the drowned lowermost part of the Susquehanna. So during glacial periods, and certainly the last one, and really many of the ones before that, sea level was a whole lot lower than it is today. So 20,000 years ago, sea level, I don't have this one in feet, I have it in meters, but anyway, sea level is 120 meters below what it is today. So that's roughly 400 feet lower than it is now. So the Chesapeake Bay was a river valley. So the Susquehanna River drained out to something farther, what's now very much offshore. So so things like the Potomac and the James River and all those were all part of the Susquehanna. So that's one piece of the story. The other piece of the story is that when we had these major glaciers that extended all the way down into Pennsylvania, there was a lot of water that came off those as they were melting. And so that water in this part of the country went down through the Susquehanna. And so, yes, there were big floods, much, much larger floods than what we see now, that undoubtedly went down through the lower parts of the Susquehanna.
Thank you.
Pete, I have a question. The graphs you showed, some of them were a bit dated, And I don't think any of them, for example, got up to the last couple of years.
Right. I haven't updated them yet.
Well, the question I have is this: is it accelerating? Last spring we had a snowfall that knocked out the power for half the county.
Mhm.
2 years ago, around Christmas Eve, we had a worship service going on, and they were evacuating the Riverview because there was concern the Susquehanna was going to flood into that
Yeah.
air facility. So are things getting increasing rapidly worse, or were those just flukes?
Well, that's the fundamental question that, we will know that in retrospect, honestly. Okay, so that's kind of, maybe that's too trivial a response, and to some extent it is, maybe not a respectful enough response. I think that, honestly, I think we are seeing what I'm seeing in particular are more intense storms that, not all of them are producing big river floods,
Mm-hmm.
but we're seeing a lot more often these storms that are producing big floods on small streams and scattered around at different places. Sometimes that gets big enough and there's enough rainfall or enough snow melt, in years, at least when we have snow, to produce big floods on the main rivers. So as I look to the future, we are already seeing an increase, clearly seeing an increase over the last several decades, an increase in the intensity of rainfall and snowfall events. Some of those are just localized heavy thunderstorms that produce flash floods. And the National Weather Service is very concerned about their ability to predict flash floods because of this increasing tendency towards intense events. Some of those become regional storms, and when they're regional storms that are intense, then we get the big floods on the rivers. I do expect we're going to see an increasing likelihood of floods over the next several decades. The Army Corps of Engineers is not so sure about it. They were waffling in their conclusion, saying, well, yeah, the storms are becoming more intense, but it's getting hotter, and therefore there's more evaporation, and maybe it won't flood as much. I don't agree with them on that. So.
Okay. Other questions from people? I have a whole different one that you didn't address, and it may be outside your area of expertise. What about water quality? How, we've had legislation over the years to try to improve overall water quality. Is it safe to drink the river? Is it safe to fish in the river? Has it improved over the last few decades, or what are the major sources of pollution in the river today?
Okay. Oh, you got a whole suite of questions that I can answer there. All right, so let's start with the major sources of pollution. Really two primary ones. One is the sewage treatment plants, and the other one is farm fields. So the sewage treatment plants have been required by the federal government to get significantly improved. And although I will say that the largest one in the upper Susquehanna, which is Binghamton's, has had its issues over recent years as they've been working to improve the quality of the water coming out of there, it has improved significantly. Other sources of pollution, industrial type sources of pollution, have really declined greatly, along with industry in general, through the Northeast. And so the river has become considerably better in quality than it was, say, 30 or 40 or 50 years ago. That's evidenced by the return of fish into areas where they had largely disappeared. And if they ever get rid of the larger dam down in southern Pennsylvania, which they've been talking about doing, there probably will be a very robust fish migration through the Susquehanna system in the future. So on the water quality side, it's significantly improved. The biggest problems in water quality in the Susquehanna occur down in southern Pennsylvania from runoff from farm fields, and that has had real problems in the Chesapeake Bay in terms of adding excess nutrients there, and farming practices are being changed in order to limit that problem as well.
So in this region, where we don't have the industry that we once did, The primary concern would get the sewage treatment plants up to snuff.
Yeah.
Okay.
Yep. And then, the groups like the local soil and water conservation offices are working with local farmers to try to improve farming practices so that there's less runoff of fertilizers into river systems.
We don't have to worry about people with stuff on their lawns, fertilizers or pesticides or things contaminating the river significantly around here.
Not significantly. I mean, yes, it does produce some runoff, but a lot of that gets trapped within sewage systems.
Okay.
Yeah.
We've got a couple raised hands. Bob, I see you there at the top of the screen.
I think Maureen was first.
Okay, Maureen, take it away, Maureen.
Hi, how often do municipalities or other agencies contact you for your expertise?
Not that often, actually. So I will work with people when I have a chance. I've tended more to just kind of give public talks like this when asked. I don't want to claim that that I can provide all of the answers to people and to municipal agencies or municipal governments. So I haven't really, honestly, I haven't really advertised any attempt to do that.
But now with this publicity, everybody will.
Well, maybe.
Bob?
I think after the 35 flood, the Whitney Point Dam and Reservoir was constructed to help alleviate future floods. And then
Right.
after 72, there were several smaller flood retention dams that were built in Broome County, Finch Hollow, Stella Ireland Road area,
Yep.
And others. But after 2006 and 2011, no additional flood retention dams were constructed. Did the Corps of Engineers give up or run out of money?
So let me first comment about the dams that do exist. So I take the Corps at their word on some of these things that they've done the calculations. The Whitney Point Dam is operating effectively to reduce some of the flood peaks, but it's on a tributary of a tributary. So once if you have a regional storm like either the 2006 or 2011, the impact of a single dam like that is it's not zero, but it is not huge. I noticed that when the 2006 flood occurred, there was the flood peaked in Binghamton and was dropping, and then there was a little rise again, and that rise occurred when they had to jump a whole bunch of water out of the East Sydney Reservoir so that it didn't burst the dam. So sometimes dams are effective at reducing the flood problems. Sometimes they can actually, unfortunately, exacerbate or at least extend out the duration of floods. I mentioned that the Corps of Engineers had done a study. So they did a study that they finished up about, I think, 3 or 4 years ago of the Upper Susquehanna Basin. And they were asked by the state to actually look seriously at what would be cost effective in terms of trying to do engineering projects to improve flood protection in the region. And they ultimately concluded, whether people may or may not like it, but anyway, they ultimately concluded that there really wasn't anything that was going to be cost effective, convincingly cost effective, that they could bring back to the government for funding. So that's why I think a lot of groups like there's a group called the Upper Susquehanna Coalition, which is a group of the regional soil and water management people, as well as a lot of local officials, as well as a number of experts who get together and have been looking at and trying to work on providing additional locations for, especially in some of the smaller streams, the headwater streams, for places where floodwaters can be held, like literally recreate wetlands and things like that, to provide opportunities to slow down the rate at which waters get into the main rivers.
Other questions or comments from folks? I think we can wrap it up. Just a reminder, if you go to our church website, you'll see at the bottom of the homepage a link to YouTube. And in a couple of days, this recording will be there, and you are welcome to share it with other folks.
Pete, do you still live in Owego in that same house?
I live in Endicott. But yes, I do still live in the same house.
Okay.
And yes, I do look out my kitchen window every so often, or my upstairs window, to see how high the river is coming up when I know it's coming, and see. Let's see. Okay, how high is it coming? We've gotten groundwater coming into our house on more than one occasion, into our basement, but we've never. I mean, as I said, I'm not concerned about river flooding impacting us.
I'm curious, we had a daughter who just in the last year bought a home not far from here. And now online with the housing listing, they show you the potential hazards from climate change, flooding, and other potential things. In the scientific community, are those real estate evaluations accurate, do you think?
It really depends on which version of flood potential they're looking at. I mentioned early on in my conversation, or my notes, or my talk, that that FEMA had reevaluated flood potential, and they did this not just around here. They've been doing this nationally, required by Congress to do this, because when floods occur, it may require that you start relooking at, well, how likely are floods of a certain size to occur in the future. When they did that in this region, while I personally have some concerns of how they did some of their work, they concluded that in Broome County here, I'm not sure how much in Tioga, but I know in Broome County there was something like 6,000 additional residences or buildings that would by definition be considered part of the flood zone that would require flood insurance. And the local municipal leaders said, no, you can't tell us this. And so my guess is that I have not looked at this on the real estate side, but my guess is that the real estate indicators are simply utilizing older maps that I think probably do underestimate to some extent the potential for flooding, and which areas have potential for flooding.
I don't have a lot of respect for politicians who do that. I'm mindful of the recent earthquake in Turkey, where there were standards for housing, and one community followed those standards and were able to get through that most recent earthquake pretty well. The neighboring one, where the civil authorities permitted people not to follow the safety guidelines, caused incredible loss of life. I don't think our political leaders do us any favors by downplaying potential risk.
I agree. Yeah.
Now, I'll ask you to do something that the correct answer in my line is God only knows, but what would you say is the probability of another 2011 for Owego? How soon?
You already gave the answer. God indeed only knows. Floods are basically random events. Mm-hmm. So when we talk about floods, we talk about probabilities, likelihoods. We don't talk about certainties, and that's true with most natural hazards. Are we going to see a flood that size or larger within, I don't know if I want to say my lifetime. I don't know if I want to say somebody's lifetime who's already in their 80s, but within my children's lifetime? Probably. I think it's pretty high likelihood, but I don't know what that number is, and I certainly can't tell you when.
Okay. I do think climate change is growing in its potential impact, including the intensity of storms. So
yeah. Yes, I agree. I think that's become increasingly clear.
So the more we can do in our personal lifestyles to counter that as well as government policies, the better. New York State has done better than most states, but we still have to implement it.
Right.
Other questions or
Yes.
comments? Well, folks, you may have heard sometimes religion and science are in conflict. I completely disagree. I think they are in partnership, and some of the best scientists have also been people of deep faith.
Yes.
So we are very grateful for Pete's work and ask that you all show your applause and continue to support our state universities that truly are a blessing to
Mm.
all of us. And thank you, Pete, very much.
Well, thank you all very much as well. And thanks for all the questions.
All right. Thanks, everybody. Have a good evening. Take
You
care.
too.
Good job.